Hello everyone. Today let's discuss the problem. Just give me a second, 1 second. What happened to this one? Yeah. Let's discuss the problem now and the pictures. Right. So this is the easy version of the problem. So let's solve this. Right. So this was asked in the Codeforces Round 564 for the division 1. Right. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So just give me a second. Yeah. There are n pictures. So what the question states here, there are n pictures, right? So each with the initial weight w, each with the initial weight w and a like flag ai, and the like flag a basically, right? And the like flag a. So one is represented for the likes basically, and 0 is represented for the dislikes, right? So 1 is represented by the likes and 0 is represented by the 0 is represented for the dislikes basically, right? So just keep these things in the mind. This is first thing. Now on each m visits, right? So someone will visit the picture, right? So on each of m visits, one picture is picked proportionally to its current weight, right? So on each of m visits, each picture is picked proportionally to its current weight, right? So if liked, its weight will be +1. If the picture is liked, then its weight will be weight +1, right? So this one I can just write it on this way, right? Otherwise weight will be weight -1. Otherwise weight will be weight -1. This is fine. I hope this part is clear, right? These two parts are clear. Now what we need to do, what is our goal basically, what we need to compute here, we need to compute the expected final weight of the each picture after m visits. See, after m visits what we need to do, we need to compute the expected final weight, right? So we need to this one, compute the expected, this one, let me write it over here, final weight, right? So that's what we need to compute here basically, right? Again, what we need to compute here, we need to compute the expected final weight after each picture after m visits, and we have to print the modulo value they have mentioned here. See this one, I'm rounding up this one, this value we have to use, they have strictly mentioned in the question, right? So we have to compute the expected final weight of the each picture after m visits, and we have to print it print its modulo, this one, 9982444353 as value into inversion, this one of denominator mod, right? So this one, let's see, I hope this part is clear, man. What we need to compute, we need to compute the expected final weight of the each picture after m visits and print its modulo value, right? So this is fine. Now again, let me read out the question completely so that we understand this one clearly before moving into the this one, input output part and the approach, right? So now we have n pictures, there are n pictures basically, each with the initial weight w and like flag a, right? And the like flag a. 1 is represented for the likes and 0 is represented for the dislikes, right? So on each m visits, this part, second part, on each m visits, one picture is picked proportionally to its current weight. If the like if it is liked, then its weight is weight +1. If it is disliked or otherwise, weight will be this one, weight -1, this part. Fine. Now what we need to compute, we need to compute the expected final weight of each picture after m visits. Simple. And we have to print its modulo 9982444353. Just remember the modulo value, right? So this one. And also what we need to compute, we need to compute the expected final weight of each picture after m visits, right? So just keep this in mind. So I hope the question part is completely clear, man. Easy, right? So let's move on with the example part here, input output part basically, right? So here I'll just explain the input output and then let's move on with the approach. So see here, this 2 1 is nothing but n we have been given 2 and m we have been given 1, right? So this part 2 3 they have given, so this is nothing but n and 3 is nothing but m1. N we have been given 2, m we have been given 1, and array we have a equals 0 1, right? Array we have a equals 0 1. And what about this one, weight weight w equals, we have been given 2 comma 1, right? So weight w equals 2 comma 1. This is fine. Now n we have been given 2 and m we have been given 1. A array, this one 0 1, and weight we have been given this one. So a is nothing but the not this one, basically what do we call, a flag, right? Likes and dislikes. So this I got confused. This is in the form of array itself, basically. This is fine. So this is dislikes and this is like, basically 0 is dislike, this one is like, right? This one is nothing but the weight, right? So there are n pictures, each with the initial weight w they have mentioned in the question, right? So this is nothing but the weight 2 comma 1. So output that we need to get here is this value, because we will be going with a modular value, this one they have given here, right? So this one. So output that we need to get here is this one. So I hope input output part is clear. We are not discussing how we got the answer here. I just wanted to explain what are these things, and this will help us in the approach part. Basically for the approach I'll be considering the example 1, this one, so that we know the input output part correctly. So it will help in the, just give me a second here, it will help in the calculation, right? So computation, and we'll be discussing about the what data structures we'll be making use of, what will be the approach and other stuff step by step, right? So let's see the same thing within the approach, right? So the output that we need to get here is this one. Again, I'm insisting you to try out the same thing whatever we discuss right in the approach. I'll be considering the example 1. You can just implement the same thing for the input 2 or the example 2 or the input 3 or the example 3, right? So don't just blindly follow, just try to implement the same thing for the example 2 or the example 3, so that you understand the problem correctly, man, right? So this is what I wanted to say. Now as we are completely familiar with the question and the approach, input output, let's move on with the approach part. So here I have considered the same first example that they have given in the question. So we have 2 1 0 1 and 2 1, right? So this is nothing but n, this is nothing but m. We know this one 0 1 is nothing but the a, likes and dislikes. This one 2 and 1 are nothing but the weights here, right? So the output that we need to get here is this one. Let's move on with the step by step this one explanation. Before that, so we will be making use of the dynamic programming along with the modular inverse, right? So again, just remember this, we'll be making use of the dynamic programming along with the modular inverse, right? So let's move on with the step by step explanation. N we have been given to, m we have 1, a, likes and dislikes we have this one 0 and 1, weights we have 2 1, right? So let's go with the initial group total, right? So we will be keeping track of 3 things. One will be going with a bad sum, another one will be going with a good sum, and another one will be going with a total. These 3 things, right? So bad sum initially this is 2 and the good sum is 1. So this part, weight, initial weights, it comes with the picture comes with the initial weight, right? So as they have said in the question. So 2 1, bad sum is 2, good sum is 1, and the total that we got here is 2 plus 1 is nothing but 3, right? So first let's go with the different, we'll be going with the different probabilities, and first we will be going with the one visit probabilities, right? So only one visit, right? So one visit probability. So what we will do here, so this is the probability to pick any bad picture, right? Not the good picture. We'll be going with the good picture as well, no worries. First we'll be going with the probability to pick any bad picture, right? So this one will be bad sum by total. Bad sum we have the value 2, and the total we have here as this one, what do we call, total we have here as 3, right? So this will be bad sum by total nothing but 2 by 3. This is fine. Next let's move on with the this one, good picture, right? So probability to pick any good picture, probability to pick any good picture will be good sum by total. For the good sum we have the value 1 here, for the bad sum we have the value 2. This is nothing but the bad sum, this is nothing but the good sum, right? So for the good sum we have the value 1 here, bad sum we have already considered, bad sum by total. This one for the good sum will be going with good sum by total. This one will be 1 by 3. This is fine, simple. Now the outcomes after that particular visit, so we'll be going with the outcomes after that particular visit, right? So if bad is picked, then probability will be 2 by 3. For the bad it is for the bad picture it's 2 by 3, and for the good picture it's 1 by 3, right? So this one let me give here BP, and this one let me give here GP, right? So here if bad is picked, probability would be 2 by 3. The chosen bad picture's weight is 2 to 1, and good stays 1, and the final weight says 1 comma 1, right? So again, if bad picked, probability 2 by 3, this one, the chosen bad picture's weight 2 to 1, good stays 1, right? So the final weight would be 1 comma 1 if we have picked the bad, right? Simple to understand. Next, let's move with the same thing. Let's move on with a good. If good is picked, right? So if good is picked, then probability we are choosing 1 by 3. So the chosen good pictures would lead to 1 to 2, right? So bad stays 2 here, right? So the final weight would final weights would be 2 comma 2 instead of 1 comma 1, right? For the bad, if we have picked bad, it would be 1 comma 1. If we have picked this one good, this one bad, so this one good. If we have picked good, then it would be 2 comma 2 final weights, right? So the final weights would be 1 comma 1 for the bad, final weights for the this one. If we have picked this one good, it would be 2 comma 2. So expected weight of each picture, let's calculate the expected weight of each picture. For the picture 1, so we will be going with this one bad, right? So for this one is for the bad, 2 by 3 into 1 plus this one 1 by 3 into 1, right? So 1 by 3 into 2, sorry, 1 by 3 into 2 because the final weight should be 2 comma 2 for this one bad. So this will be 2 by 3 plus 2 by 3 basically. This would lead to 4 by 3, right? So for the picture 2, we'll be doing the same math. Basically it would lead to the same result, right? So 4 by 3, right? So this one will be 4 by 3 and 4 by 3 for the picture 1 and picture 2, right? So 4 by 3 and 4 by 3. So we will be converting that 4 by 3 to the modulo value that they have given within the question. They have strictly asked us to go with the modulo value, right? So we will be going with the modulo inverse of 3, which is this one, 3327481118, right? So now we'll be going with 3 into 3327481118, which is equivalent to 1 mod this one, right? 9982444353 basically. So this is the value, mod value they have given in the question. So 4 by 3 mod this particular so the output that we got here is for the good picture and the bad picture. We got 4 by 3, right? So now we will be going with 4 into this one, right? We are going with a modulo inverse mod this one, 4 into the value this value basically 3327481118. So the value that we get here is this one, right? 13309272472 basically. So then this would lead to the this one, 3327481119 modulo this one, 9982444353 value, right? So this one is the basically final output. So this is the final output, right? So this one is the final output, 3327481119. So both pictures have the expected weight this one after this one calculating with the modular inverse, right? So after going with the modular inverse, so we have got the value 3327481119 for the both pictures. Both pictures have the expected weight. This one we have to go with the expected weight, right? So we need to return the expected weight. So both pictures have the expected weight 3327481119. So we will be this one displaying the same thing, or we will be returning the same thing in the form of output, the final output. So the output that we got here is 3327481119, which is equivalent to the output that they have mentioned for the example 1 or the input 1 within the question. So our approach works absolutely correct in this case. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what would be the time complexity here? So the time complexity would lead to big of m square here, right? So the time complexity would lead to big of m square, because as I have said, we'll be making use of the DP, right? So I said we will be making use of the DP or the dynamic programming. So DP iterates over all the pairs, this one b comma g. DP iterates over all the pairs this one b comma g with b plus g less than or equal to m. B plus g less than or equal to m. So each transition constant time this is for the each transition constant, this one time modulo operations, right? So overall time complexity would lead to big of m square. So what would be the space complexity here? The space complexity would be big of m square plus n. So why it is big of m square plus n here? So dp table here, that would lead to big, that is of the complexity m square, right? So dp table is of the this one, it requires big of m square, right? And also we are making use of the arrays of size n. So overall space complexity would lead to this one, big of m square plus n, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m square n, big of m square n, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code here. So one thing, so we'll be making use of the fast input and output. Let me import here input output package. So I'll just go with start. Now let's make use of the different utilities. We'll be making use of the different utilities as well. I'll just go with, let me import utilities package as well, right? So I'll just go with util.start. Sorry, just give me a second here. Yep. Now let me go with the class name main. As usual, you can just give any class name that's relevant to the question, right? So this is fine. Now first initially let's go with the maximum size for the arrays of pictures, right? So let's go with the safe upper bound. So I'll just go with the value here, static final int max n equals, so here 2000, this one 10, right? So this is fine. Next let's go with again static final, so this one int instead of the n, let me go with max m here. Let me assign this one to the value 3010. So sorry, 3010. So this is nothing but the maximum dp dimension, right? This consists of safe upper bound, right? So m less, it has to be m has to be less than or equal to 50 here, right? So we have considered the value 3010. Initialize this one with 3010. This is fine. Now we have to consider the modular value as per the question, right? They have strictly mentioned. So I'll just go with static final int, so mod, let me come here to the question. So let me copy the mod value here, this one, right? Copy this one and paste it over here. This is fine. Now we are left with some more initialization part, right? So we have to go with the number of pictures and number of visits as per the question. So I'll just go with the static here. So int, let me initialize and then m, right? So nothing but number of pictures and number of visits. Next, we have if type of I equals 1, nothing but if we have liked the picture, the type of I will be 1. If we have disliked the picture, if anybody has disliked the picture, and the type of I will be 0 basically, right? So this will be one indexed usage, just remember this one, right? So let me initialize this one static long here. So let me go with the type here. Let me assign this one to the new long of within the array. Let me pass max n, right? So this is fine. Now we have to go with the initial weights w of I. If you remember, this is also one index, just remember this one. So let me initialize this one static long, so this one will be weight. So let me assign this one to the new long of this one. Again, let me pass max n here, this one. Fine. Now this is also fine. We have went with the initial weights. Now let's do one thing. Let's go with the dp of bg, nothing but the probability mod of this one, b bad pics and the g good pics, right? So b bad pics and g good pics, if you remember the approach. So let me assign first, let me initialize the dp array. Static, so here this one will be long, dp, this one will be new long of max m and this one max, this one has to be max, yeah, both are max m itself, right? So max m itself. Now this is fine. Now let's go with the accumulators, the final one. Let's go with the accumulators. So I'll just go with the static here, long. So we went so I explained you about the good sum and the bad sum. So we considered good sum, bad sum, and the total, if you remember, within the approach, right? The same thing. Now let's go with the long. Sorry, we don't need array here. So this one, initially let me go with a good sum and initialize this one to 0, and let me go with a bad sum and initialize this one to the 0, and let me go with a result good and let me initialize this one to the 0, and also let me go with a result bad and let me initialize this one to the 0. These are nothing but the accumulators, right? So this is fine. Now let's go with the fast modular exponentiation, also used for the modular inverse, right? Via exponent is equal to mod minus 2, right? So mod hyphen 2 or mod minus 2. So let's go with the fast modular exponentiation. Nothing but I'll name this method modulo power or mod power, right? So nothing. So I'll just give you a static long. So this one will be mod power. So I need two parameters, one is base and another one is exponent, right? So I'll just go with the base. So another, for the exponent, I'll just go with exp. This is fine. One more thing, we'll be discussing many algorithms within the this one in the Python, basically number theory algorithms, right? So this will include this one as well, modular inverse as well, if you don't know. So you can wait till that, right? So we have discussed some important algorithms while we were solving the problems on the this one, same Codeforces problem using Node.js. So again, mainly I'll be solving on this one, right? Java. So we'll be discussing this one using Python and Java both, right? So if you don't know, so I just wanted to tell this in the future, right? So for now, let's continue with let's continue where we have stopped, right? First, where we have stopped, just give me a second. Yep. First, within this method, so we have to go with the result accumulator first. So let me initialize this one to 1, right? So let's bring the base inside modulo range, right? So I'll just go with base equals yep. So this one will be mod, so this is also fine. Now let me go with the while loop here on end greater than 0. This is fine. So we are going with a binary exponentiation loop here. So within this while loop, we have to multiply when current bit is 1, right? So we have to multiply when current bit is 1. So let me go with here exponent, so bitwise AND operator here, and 1. So if it is equivalent to 1, we have to multiply this one, right? So I'll just go with result equals result into base modulo. So let me pass the mod here. This is fine. Now the next step after the if condition, let's go with a square base, meaning here base equals base into base modulo mod. So this is fine. Now the final step is let's go with the shift exponent, nothing but exp right shift operator. This is fine. We are left with only one step, nothing but we have to return the result. Result is nothing but the base to the power of exponent mod mod, the big mod, right? So we have discussed this one in the approach. So I'll just go with here return exponent, right? So this is fine. Now we are done with this part. Let me come out of this one entirely. Now we are left with main method. So let's go with the main method here. So this is fine. Let me remove this. Also let me include here throws input output exception. I'll just go with input output exception, right? So this is fine. Now within this method throws input output exception, whatever I have given here, let's go with the fast input first. So I'll just go with buffered reader, this one br equals new buffered reader new input stream reader. So this one, let me go with system.in. This is fine. Next step is, let's go with a print writer for the output, right? So I'll just go with print writer. Let me go with out here, or pw, anything you can go with. I'll just go with out here. So new print writer of new, so let me consider here buffered writer new output stream writer of this one, system dot out. So this is fine, man. Now let's go with the string tokenizer. I'll just go with string tokenizer. So this one, st equals new string tokenizer buffered reader dot read line. This one is fine. So we are just reading the first line. Now let's go with the n and m, nothing but number of pictures and number of visits, like right. So this one will be n equals integer dot percent. So this is fine. String tokenizer dot next token, the same thing. Let me copy the same thing then here. Just give me a second here. Yep, this is fine. This is also fine. Let me give m here. This is also fine, man. Right, so this is nothing but the number of pictures and number of visits. Next, let's go with the string tokenizer, right? st equals new string tokenizer. So this one will be buffered reader read line. This is also fine. We are just reading the types line here. Next, we have to store the a, right? So in the form of 1 to n, right? So a is nothing but the flags, right? Like and dislike. So we have to store that one. How can we do that? Let me go with a for loop here. This one will be int I equals 1, I less than or equal to n. So let me increment this one. So we are going with the type, right? So type of I can just go with let me assign this one to the long. I'll just go with long, this one pass long of string tokenizer dot next token. This is fine. We are done with this part. Now we have to read the weights line as well, right? So in the question, what are the input in the input part? This one we have went with this one AI also we have went with nothing but a flag, likes and dislikes. Now we have to go with the weights, right? So for the weights, let me go with string tokenizer, this one new string tokenizer buffered reader dot read line. This is also fine. So we are just reading the weights line. So let me go with the for loop again. So int I equals 1, I less than or equal to n, I less plus. So within the for loop, so we have to store the w, nothing but the weight, wi, also known as w. So this one weight of I equals, so let me go with long dot parse long string tokenizer dot this one next token. So I should have copy pasted. It's fine, man. Now let's write the simple if condition for this one. So we have to go with the sum of like pictures also with the initial weights, right? So I'll just go with the if condition here. If type of I equals 1, then let me go with the good sum equals good sum plus weight of I. This is fine. Else let me go with the bad sum equals bad sum plus weight of I. So this one will be weight of I. Simple. Let me come out of this one entirely. Now as I have said, we'll be making use of the DP, right? So we have initialized the DP array. So now let's go with the classic DP here. Let's go with the 0 bad picks and 0 good picks with the probability 1. So let's consider DP of 0, 0 equals 1 here. This is fine. Now let's start filling the DP. Means we have to iterate all the states with b plus g less than m and distribute the probabilities to the next states, right, accordingly with the approach that we discussed. So this one I have said it multiple times. I had stressed this one, right? Here one more thing. Here the first index is b, nothing but the bad pick so far, and the second is g, the good pick so far. Just remember this one. This will be very important, or else you might get confused with the bad and this one good picks, right? So the first index is b, nothing but the bad pick so far, and the second index is g, this one good pick so far, right? So what we will be doing, we'll be iterating over this one. We will iterate all states with b plus g less than m and distribute the probabilities to the next state. So let's go with the two for loops here as discussed. So this one will be int I equals 0, I less than m, I plus plus, right? So within the for loop, let's make use of one more for loop. So this one will be int j equals 0, also comma sum equals 1, sorry, not 1 I, right? So sorry, I got confused. Sum less than m, this is fine, j plus plus, along with we have to increment sum as well, sum plus plus. So within this for loop, what we will be doing, so we know one thing, that j corresponds to the big pick, this one good picks g, right? So condition sum has to be less than m, basically, which enforces I plus j has to be less than m, right? So let's try to implement the same thing in the form of code now. So this one will be long total now. So this one will be good sum plus bad sum. So this one plus j minus I. So we have to make use of the modular value as insisted, right? So this is fine. Now let's do one thing. Let's write the simple if condition, because we have to make the this one positive mod, right, or the mod positive. So this one, let me go with if total now. If it is less than 0, then we have to make it positive as well. So this one will be total now plus equals mod. This is fine. Now we have written the modular power, nothing but the modular inverse function, right? So we will be making use of it now, right, within the main method. So we will be going with the modular inverse of the current total weight. We have to go with the modular inverse of the current total weight, right? So that is the reason we have made use of the helper method modular of this one mod pow I have written, right? So this one will be long. I'll just go with the inverse here, I and b. So this one will be mod power. So this helper method we are making use of, basically this one, right? So let me copy this one and paste it over here, the same thing, power. So this one will be total now comma mod minus 2 as we discussed earlier. This is fine. Now we are left with some more steps here. We have to go with the so the code is big actually. Still we have to write still we are left with many things actually. Now we have to go with the transition part, meaning we have to pick a bad picture next, right? So we have we have to pick a bad picture next. So probability as discussed in the approach, we have went with bad sum minus I by total now. Also we have to multiply dp of ij by that, right, and add to the dp of I plus 1 into j, right? So we are just articulating the same thing in the form of code, whatever we have computed, if you remember, right? So now let me write it on this way. Long bad availability, I'll just write here avail. So this one will be bad sum minus I. So this one will be modulo mod. So this is fine, man. Now let's go with the simple if condition. So this one will be bad availability. Again, if it is less than 0, then so I'll just go with bad avail. So this one is fine. This one is mod, right? So this is also fine. Now dp of I plus 1, so this one j equals dp of let me go with I plus 1 This is also fine. J plus and J plus, so let me go with dp of I j here. So this one into bad availability, so this one modulo mod into inverse mod. So this one is fine. Yeah, now let's do one thing. Let's go with a transition, this one. Now we have already picked a good picture, right? Next let's pick a previously we had picked a bad pick, right? So this one from 53 to 55 basically. Now let's go with a good pick basically, right? So let me copy the same thing and make the necessary changes for the this one good pick. So I'll just copy paste this one. Instead of the bad available, I'll just go with a good available. So instead of good sum, let me go with instead of bad sum, let me go with the good sum here. Good sum. Instead of plus, so instead of minus, I'll just go with a plus. Instead of I, I'll just go with j modulo mod. This is fine. If good availability, not the bad availability, so this one, if good avail is less than 0, then it has to be again good availability plus equals mod, right? So this is fine. dp of I, this has to be dp of I j plus 1. This is fine. This will be dp of instead of I plus 1, this has to be I and j plus 1, right? So this is fine, plus dp of ij, this is also fine, into good availability. So this one I'll just go with good avail. So this is also fine, modulo mod into inverse modulo mod. This is also fine, man. This everything remains same here. So now we have went with picking a good picture as well as the bad picture first and the good picture next, right? So probability for the good picture was bad sum minus I by total now, and then we multiplied this one dp of ij by that, right? For the good picture it was good sum plus j by total now. That's it, right? So now we have completed that part. Now we are done with that part. So now we let's do one thing. Let's move on with the further things. After m picks, we have to go with sum over all the states with b plus g equals m, right? Just to compute the expected total, right? So how can we write that one in the form of code? Let me go with the iteration part here. So let me come out of this one entirely. So here what shall we do? So this one will be for int I equals 0, j equals m, so I less than or equal to m, so I plus plus, we have to decrement j right here, j minus minus. So now let's go with the probability of reaching the exactly I bad picks and j good picks, right? So this one will be long. So let me consider index value here. I'll just go with idx val here. This one, let me assign this one to the dp of I j. This is fine. This is easy, man. Now let's go with the bad total of the I bad picks, and also we have to go with good total of the j bad picks, right? So first let's go with the bad total of the I bad picks. So let me type this one quickly. Long current bad. So this one, let me go with the bad sum minus I modulo mod, and if current bad less than 0, then current bad equals current bad plus mod. So now we have went with the bad total of the I bad picks. Now we have to go with the good total of the j good picks, right? So this one, let me go with long current good. Let me go with here good sum plus j modulo mod here. This is fine. So this time if current good is less than 0, then current good we have to add this one to the mod. We are done with this part as well, almost. Right, so now we are left with only two things. We have to accumulate the expected totals, nothing but sum of this one, sum dp of state into current group total. Right, so I'll just go with result bad and result good here. Right, so this will be the correct naming, variable naming. So this one will be result bad plus index value into so this one has to be current bad, right, not the current good. Current bad. So let me copy the same thing and make the necessary changes for good result or the result good. So this one I'll just make this one instead of bad, let me go with a variable name good here. So again so let me go with result good here. This is also fine, plus index val remains same. So this one again instead of bad, let me go with good. This remains same. Right, so this is fine now. This is fine. We are done with this part. Right, so now we are left with some of the things. So we have to pre-compute modular inverse of initial group sums for this one, per picture proportional scaling. Right, so this was required. This was actually required. I didn't know why, but this one if I ignored was getting the wrong answer. Basically we are going with the we are computing the modular inverses of initial group sums for per picture proportional scaling here. In simple steps we are going with inverse of the initial good sum and bad sum. So let me do one thing. Let me come out of this one entirely. So as I've said, we'll be pre-computing the modular inverses of the initial group sums for the per picture this one proportional scaling. First let's go with the inverse of initial good sum, then let's go with the inverse of initial bad sum. First let's go with the initial this one inverse of the initial good sum. So I'll just go with long here, inverse. I'll just name this one inverse good. First we are going with the initial good sum, right? So I'll just go with if good sum is greater than 0, then we have to go with let's display here mod power this one. This method we have already written, right? So this one let me pass good sum modulo this one, yeah. Now mod comma mod minus 2, this is fine, else 0, right? So let me copy the same thing and make the necessary changes for the bad sum. So here inverse good is there, so let me go with inverse bad. So this one will be good sum. Instead of the good sum we will be going with a bad sum. If bad sum is greater than 0, then we'll be going with a mad power. So this one has to be again, sorry, just give me a second here. What is happening here? So I'll just go with bad sum modulo mod. So this is fine, comma mod minus 2, else we have to display 0. We are just going with the inverse of initial good sum and the bad sum. We have successfully written the code for it. Now this is fine, man. Now we are left with only certain things. So yep, for each picture the expected final weight will be expected group total into weight I by initial this one, what do we call, one second, we are going with for each picture the expected final weight, right? So yeah, expected final weight would be expected group total into weight of I by initial group total, right? So this is what we will be doing now. So we will be outputting the result group into weight of I into inversion of this one, what do we call, initial group total, right? So all modulo value finally, right? So let's go with a iteration now. So I'll just go with for loop and I equals 1, I less than or equal to n, I plus plus. So within the for loop what shall I do? If type of I so this one equivalent to 1, then I'll just go with out dot println. So this one will be result good into, So this one will be weight of I. This is also fine. Modulo mod this is fine. So this one actually mod into code modulo mod. So this is fine. Now this is for the liked pictures. We have to go with the disliked pictures as well, right? So this one else, so I'll just go with let me copy the same thing and make the necessary changes for the disliked pictures. So this one out.println remains same. So this one has to be, instead of the result good for the this one disliked, we have to go with the result bad, right? So into weight of I modulo mod, this remains same modulo mod into this one has to be inverse bad, inv bad, right? So modulo mod, so this remains same, right? So we are done with the coding part almost. So we are left with only one thing, that we have to flush the output. We are done with the logical part here, right? So I'll just come here, let me give here out dot flush. This is fine. So we are done with the output part, man. Sorry, coding part, man. Sorry. Yep. Now before checking the code with the different inputs or the examples, let me copy paste the signature starter template. Just give me a second here. So I'll just come here, let me come here and let me paste it over here. This is fine, man, right? So this is fine. Now let's do one thing. Let me copy this one entire thing. Let me submit this one. Let me come, let's check this one with the different inputs, right? We haven't checked that one. So let me copy this one here. Let me run the code. Oh, we have many errors, many of 4 errors. Same line, 81 error, not a statement. So here I have to give comma, I believe, somewhere. I equals 0, j equals m. Yeah, I have to give comma here. Line number 81 for I equals 0, comma, j equals m. So we have, damn, man. Just give me a second here. I equals 0, j equals m is fine. I plus plus j minus minus is also fine. So let's see what is wrong here. We are getting 0 0. Why? Just give me a second here. So what mistake I have done here is, in the line number 42 we have to return the result, man. So I have initialized result here, this one to the one. So this is the result variable basically. So we are returning exp basically. That's completely wrong. Let me run this one again. Now, yeah, now we are getting the correct output. So this was the main problem. This is fine, man. In a hurry I had typed this one, I think, exp instead of the result. So this is fine. Now we are getting 3327481119. So this value, this we have considered within the approach as well, right? The same example, we are getting the correct output. So for the second one we have to get the output 3. Let's check the same here. So yeah, we are getting the correct output, right? So this is fine, man. So now for this one we have to get this as output, right? So let's check last two, this one digits. That's fine. 862917 8629 and 17, we are getting the correct output, right? So this is fine, man. Now let me copy the entire code. Let me come here. So I had already hit the submit button, right? So this is fine. We are at the submission part. So this is problem C1, right? So C1, Nauuo and Pictures. So let me select C1, the easy version. Let me paste it over here and let me hit the submit button. I hope this works for all the test cases, man. Let's see. Running on test 1. Let's wait for some time. Running on test 40, 58. Yep. Let's wait for some time. Yeah, you can clearly see here in the tooltip it's showing accepted, right? So not the tooltip, sorry, and the toast right? So this is showing accepted. So the verdict that we got here is accepted, meaning whatever the code that we have written works absolutely correct for all the test cases, right? So purely we went with two things. One is modular inversion that comes from the this one number theory part, and the second one is DP, right? So DP along with the modular inversion, right? So that's what we are main thing. These two are the main things, right? So these things you can calculate accordingly with this one constraints that they have given, right? So this is fine. So main two main things here is, so we are going with the, or we have went with the this one basically DP and modular inversion, right? So I hope this part is completely clear, man. Whatever the code that we have written is completely clear, right? I meant to say I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.